Amazon Prime Video, they're rewriting all of their applications in Rust/compile to WebAssembly because they've seen such a big difference in performance. Today's world, where you have multiple orders of magnitude of more data and transaction, you really need to be able to look at what's going on at a higher level than logs.
Hello, everybody. Welcome back to the Stack Overflow podcast, a place to talk all things software and technology. I am your host, Ben Popper, Director of Content here at Stack Overflow, joined today by my colleague and collaborator, Ryan Donovan, editor of our blog. And our guest today is Daniela Miao, who is the co-founder and CTO of Momento, a real-time data infrastructure platform. Before that, she helped to build DynamoDB for AWS, serving as the tech lead, and was with IBM Canada's software lab. So we're going to be talking about uptime and availability, observability, and also her passion for Rust, which is always one of the most popular and beloved languages in our annual developer survey. Without further ado, Daniela, welcome to the show.
Thank you, Ben. Super excited for our chat today. And thank you for having me on the show. I'm really looking forward to all of our topics.
Terrific. So first of all, tell folks, how did you get into the world of software and technology? What led you down this path?
Mostly through dabbling with it when I was much younger and just learning programming, starting with C and C++. And then grew to really just love the application of it. And of course, with all the exciting things constantly happening in tech, keeping me interested, keeping me on my toes, including with Rust in the more recent years, especially working on it with my team and here at Momento.
Neat. So let's go back a little to the experience I mentioned at AWS, because it sounds like maybe that was formative to creating the company you're at today. What were you doing at AWS, and how did you get assigned to that particular project?
I was working on the backend engineering team for DynamoDB, which is a NoSQL database, now scaling to tens of millions, hundreds of millions of transactions per second. I got into it, actually. I was working initially on Elasticache. And at the time, I think Elasticache team was also already doing really well with their product. DynamoDB was still considered early in its development journey. So I wanted something that could show me that kind of product and technical growth. And then actually combined with AWS, subsequent to AWS, I joined a early stage startup at the time, 10 people, called Lightstep, focused in observability and tracing. I was there for 4 years. The company really also grew exponentially while I was there. And that kind of gave me combined experience in distributed systems and observability, which sort of all very much seeded the idea for Momento.
I was reading up a little bit on DynamoDB before we got started. Werner Vogels, who's CTO at Amazon, wanted to do this, especially after sort of like a 2004 holiday season where there was a lot of stress and some downtime or some failures. Do you remember going in, thinking about Amazon at scale and AWS, which I don't know what year you started, but has just continued to grow and grow. Did you think about specific pain points that you were trying to solve for? And can you tell us a little bit about sort of some of like the engineering decisions you were involved with or the build out that helped to solve for those?
Yeah, I think the biggest underlying primitive that Dynamo is very successful at is this idea of multi-tenancy. I think the idea of having a big pool of resources and being able to offer it to isolated workloads and customers without them noticing any difference in performance. In fact, what they do end up noticing is increased availability, decreased costs, so more economical costs, and the ability to absorb unpredictable spikes, which are really the underlying principles that we're trying to apply to caching workloads as well. With today's real-time applications, you really cannot, as a developer, predict the type of workload you will actually get in production. So that becomes extra critical. And I think a lot of the underlying design decisions we made at DynamoDB sort of contributes to its success today.
How does the multi-tenancy in databases work?
I think the way that you can think about it working is in traditional databases, you as a developer have to predict ahead of time what your maximum load could be. and then you pay for the bigger and beefier machines in order to account for that. First of all, it's wasteful because most of the time, if you're overestimating, then you're paying for way more resources to be up 24/7 that you don't need. We're usually not very good at predicting workloads. So if we're underestimating, then you're looking at an incident and outage during the time where you need it the most. Because if your application or if your app blows up in popularity, you want to be able to support the peak traffic, and then you have to scramble to try to figure out a live migration from a smaller instance to a bigger instance. How multi-tenancy works is there's a gigantic pool of resources like DynamoDB has behind the scenes, and it does very sophisticated workload distribution and kind of spreads the traffic over multiple machines and instances to kind of, dampen the effect of these bursts and to be able to absorb it, because you're working with hundreds, if not thousands, of machines. Today with Dynamo, I bet it's thousands. So it gives you better availability because it's able to absorb those unpredictable traffic. But then during times of no traffic or very little traffic, you're not having to pay for idle instances because it's being used for someone else's workload. So that's the beauty of multi-tenancy. And like I said, it's not as simple as that. There's a lot of sophistication to ensure that the workloads are isolated so that you don't feel the impact of other people's workloads.
These multi-tenants, are they actually sharing the same database instance or just the same cloud resources?
It depends on the exact implementation. Behind the scenes, a lot of the time it's sharing the same physical machine, and these are like large, beefy instances at AWS. So definitely CPU, things like memory. With regards to the database instances, you can choose to isolate a given customer's workload on its own database instance. You just run multiple of them on the same machine. I think that's a implementation detail that kind of evolves over time behind the scenes. And that's the beauty of it, right? Like as the end user, as long as I get my data, I get the security of my data, I get isolation of my workload, the implementation behind the scenes can always evolve to provide better performance and better cost without the end user noticing.
Yeah, you talked about that from the perspective of, hey, I don't want to have a single instance devoted to me and I don't use enough of it, then I'm paying for more than I need. Or, something goes down, now I'm noticing it, so you spread it around. You get the best of both worlds. And then you transitioned from AWS to a company that was working on observability. There, I guess, you're looking at what's using up the most resources. Do we have bottlenecks somewhere? If there was a failure, can we trace it back? Talk a little bit to us about what you learned in observability coming from the database world.
I think observability is also just a super interesting field because people often need it the most when they don't have it. So what I mean by that is when you're developing an application, observability is never at the forefront because you're really just focused on core functionality. And oftentimes in the startup world, you don't even know whether or not your product or application will be successful enough to really for observability to matter.
Right.
People tend to underinvest in observability early on, and then becomes too late and too burdensome to add it when the application is actually successful enough for observability, debugging, performance optimizations to matter. So we often at Lightstep, the startup I mentioned for observability, we often get a lot of customers coming in with a sense of urgency. I need something. I need visibility. Yesterday I want it ASAP, and there's a lot of debt that's accumulated by that point. So the way I think about it is that if you amortize a little bit of the cost of observability, you put a little bit upfront. It's very similar to testing, right? If you put a little more visibility into your application while it's small, and then it scales with your stack, then it's a lot easier. It becomes more natural to observe your system when it's under duress, and it becomes like an easy fix at that point.
Yeah, hard to convince folks to put the resources into that when, it's a small, lean team, maybe not a lot of runway, and they're trying to figure out what they need to change in the product to get that product market fit and, get a little bit of traction to get to the next round. But I hear you,
Totally.
if you have good documentation and some good observability, when you suddenly start to hit scale, things will run a lot smoother.
Totally. And I think it's a constant balance. I'm not suggesting that you kind of go all out which is why I also think it's important. And I'm happy to see a lot of the innovation in the instrumentation side as well. Like make it automatic, make it a part of the development journey so that it's not like another thing that developers have to learn. And then it's just naturally there when you copy paste code and you're kind of adding more features. It's just like automatically a part of your stack.
Right. Remind me, what was the name of the startup you worked at?
It was called Lightstep, and it was subsequently acquired by ServiceNow a few years later.
We've had a bunch of folks come on and talk observability, but it seems like most people think of observability as like almost an extension of just logs, right? You're writing some data to a file and then checking it later. What are the additional challenges and advantages of the real-time observability?
I think a lot of it now has some overlap with quote unquote analytics. Logs, I think, is very helpful in debugging and trying to figure out, what's going on. In today's world where you have, I would say, orders of magnitude, multiple orders of magnitude of more data and transaction compared to a decade ago, information overload is an understatement. You really need to be able to look at what's going on at a higher level than logs, right? Logs give you the details that you need. You need to be looking at aggregate insights is what I always come back to. Patterns, right? The machine needs to be able to give you some insight that's can be abstracted to the human level. What's happening across this machine in the past 15 minutes, in the past hour? What's happening across a set of my machines that's located in region X versus region Y, right? It's all abstracted beyond the single application, the single process level. What I worked a lot on at Lightstep, tracing insights, aggregate insights, metrics designed to give you kind of aggregate, how's my system doing overall? And I think that kind of goes into a little bit of almost like analytics, not just about debugging an issue anymore. It's about predicting where my system is spending a lot of the time and resources so that I can optimize my system and catch outages before they happen.
So I noticed on the resume that got sent over, it said you also worked at IBM Canada in a software lab. Was that before or after the experiences we've been discussing?
That was before. That was actually when I was doing a co-op still when I was in school. That was kind of the beginning, I guess, of getting to know databases in general. And then that was followed by Dynamo.
So yeah, I mean, you've had really interesting experience as a developer. You got to work inside of a big company on a new product, which was kind of fun. Then you went to a startup, from 0 to 100 people, and then that got acquired. And now you're in this new position of co-founder and CTO, and you've raised venture capital. You're trying to create your own thing. So I guess what was the inspiration that led you and your co-founder to decide this is an idea we can build a business around, and kind of that genesis of how it got started?
I think it was sort of natural for us because we both had the startup itch. Obviously, I had been through sort of a complete life cycle from being early to getting acquired. So I thought that journey was really, really interesting and kind of stretched me in ways that I couldn't imagine. So I wanted to sort of do it from the front row seats. So Quadra, my co-founder, and I were exploring different ideas, and we started by really just becoming application builders. We were building this fitness app that we, thought had some impact, real life impact at the peak of the pandemic. Try to help others. And in building that app out, we realized, well, first of all, we weren't very good app builders. We're infrastructure, we're platform builders, but we did discover multiple pain points, and that's the point, is to discover problems and think about how our experiences would fit. And manually managing multiple caching clusters was definitely a pain point for us personally. And we started doing more user interviews, found that it was a pain point that others could resonate with. And we saw this, I mentioned this paradigm of sharing resources in a more sophisticated manner via multi-tenancy, and didn't see that apply to the caching world at all. I mean, it's been done in the database world, not just with Dynamo, but things like Mongo and as well. So anyway, we thought that there was something here, pitched it, raised money for it, and has acquired design partners in production, and that's kind of our first product, is the Momento caching product in the real time infrastructure world.
I've sort of thought about caching as like a single in and out, but what's the the problem you're talking about here? What is the multiple part of the caching?
Caching is usually used as a load shedding layer. I mean, it's a performance layer for sure, but it's oftentimes also used to front a lot of the traffic that would otherwise go to the database, right? So, think of everybody turning on their TV during the Super Bowl and watching the same ads. If it's served from some database, you're getting millions of transactions hitting the same database in the same second. And databases aren't usually designed for that kind of bursty, unpredictable traffic. I mean, that's why Dynamo became so successful. But even DynamoDB, in order to provide database guarantees, has hard limits around how much you can query a given item in a given second. And that's where people usually put a caching layer to be able to serve those requests very quickly in a short time period. So caching sees bursty activities even more often, and the peak to average ratio is even higher than databases. And yet, the caching world, in terms of platform provisioning and capacity management, is still very much the same as what we had to do with databases back in the day. You choose an instance type. It gives you a limited set of resources, CPU, memory, network bandwidth, connections, and that's what you get. And if you get bursty activity that goes above those limits, any of those limits, you start getting errors, your application starts suffering. So again, the same set of problems. So we just thought that by making these again, sophistication around multi-tenancy, where you have a big pool of resources dedicated that could be utilized for your cache when it has bursty traffic. And then when it doesn't, it can be utilized for someone else's bursty traffic. So that really plays to our advantage in terms of how we're able to offer better availability and at cost-effective levels to our customers compared to traditional caching and provisioning. I mean, this is just about dollars cost and infrastructure, but if you include the mental burden of having to benchmark, predict, and hope that your cluster size is big enough during your biggest event, then I think the value goes up exponentially.
Nice. Yeah, I remember seeing you had clients like Paramount and Taco Bell. We had someone on recently from Shopify, and I can imagine Paramount, the Olympics, right? Like suddenly you've got this burst of activity, or Taco Bell, you're running this kind of weekly special, and one of them just happens to, hit the right zeitgeist, and all of a sudden everybody's, using the app all of a sudden. There were a few other things on your site alongside caching. Topics and storage. Storage is coming soon, so you want to tell us a little bit about topics?
I think the interesting thing, if you look at AWS, the interesting thing about being an infrastructure provider is that people often have multiple levels of problems or pain points with their infrastructure. And when they start using you for one, they start talking to you about other problems that they're having. And the interesting thing about what I said about this paradigm of multi-tenancy and resource sharing is that it's not limited to databases or caching. You can apply this to all kinds of resources. And so with the same architecture, we are able to come up with different lines of product. So caching is for obviously performance and load shedding reasons. And then topics, which is our real-time pub sub service, is for instant delivery to many, many devices. So if you think about chat or video comments, emoji reactions, where you kind of have one single source, somebody reacts, somebody posts a comment, and then you have to instantly propagate that to potentially millions of users who are watching a stream or playing a game. So this problem is, again, very bursty in nature and unpredictable. So, the same underlying computer engineering, computer science paradigms get applied here. And that's what Topics is sort of here to do, is if you need instant delivery to up to millions of users at scale and with this bursty nature, that's what Momento Topics is designed to do. And especially in things like media, so, Paramount, streaming, sporting events, where it's like one-to-many relationship, gaming. Gaming is a big vertical for us as well, where, chats and you can think about these things like raids, tournaments, right? Where a lot of people come together and you need things to be instant, because guess, what a bad experience it would be for one player to get information with a few seconds lag from another player in the tournament. So that's what Topics is. And then storage, I'll just talk a little bit about, naturally, when you want to have a caching layer, you have a database that you're trying to, work with it. A lot of our customers they might be building a new application and they kind of want like a one-stop shop for both caching and their durable data. So really for us, it's extending our architecture to work with databases as well. And that's what Momento Storage will be.
I know in the initial contact, we talked about Rust, and Rust is a big, well-loved language in our survey. Every year it tops the charts. I'm wondering how Rust plays in, and how do you think it improves, especially like the real-time nature of this? So if you could talk a little bit about what Rust does for you.
Yeah, for sure. I think probably a lot of the folks in the audience is familiar with the performance benefits that Rust offers. I think a popular saying is that it gives you higher level abstractions as a language paradigm, but then the performance of lower level languages like C and C++. That's the reason that we started exploring it in the first place. Most of our stack was actually written in a JVM based language in Kotlin, because initially most of our engineers were very familiar with developing and debugging in Java or JVM based languages. Once we reached the point where we saw that there was basically not too many low hanging fruits left with performance optimizations within the JVM, and a lot of it is caused by a garbage collection, the classic characteristic of JVM. We started looking at other languages, obviously the traditional C, C++ versus Rust. And we did find that the way that Rust is designed with memory safety in mind, right? It gives you guardrails that you cannot work around, where you have to think about a lot of things ahead of time. Its ownership model forces you to think about, who owns this variable, when you can let it go, immutability. So it sort of teaches you these concepts that you must learn in order to even develop in it, which seems like a little bit of tax that you pay at the beginning to be able to develop much faster in a way that prevents you from making errors when you're developing, and it catches errors very early on during compile time. By the time that the program compiles and runs, it compiles to binary and it does run with, again, as if you had written it in a lower level language like C and C++, which kind of gave us a step function in terms of improvement, in terms of optimizations. And us being a real-time platform, performance is in our DNA. We need to be faster. We need to get cheaper, and we need to be able to serve more requests per second constantly to be able to sort of stay competitive. So I think for us, choosing Rust and really like migrating our core services over to Rust has been a game changer.
I hear a lot of folks, talk about fighting with the borrow checker and complaining about the Rust ownership model, but it's an interesting way to think about it, that it almost makes you think about the program in a different way. Do you think there's ways to take that way of thinking about memory safety to other languages?
I think that it depends on how much things like performance and scaling with performance in mind matters to a given application. It's hard for me to answer it in one broad stroke, because I understand that for some people an app is an app, and they're sort of making a lot of these, and then more than half of them won't be successful. And then when it's successful, maybe they can work on optimizing. For us, when we work on an infrastructure platform, when we're down, our customers are down. So we have to think about performance and reliability as a part of our DNA, because the negative consequences are too crucial, too significant. For us, I think, like I mentioned, that little bit of tax that kind of forces you to think about the ownership model ahead of time prevents us from inadvertently committing things like data races, which is almost impossible to observe and to catch early on. And then like really, really, a big pain to debug later on during runtime. So the one thing that I've heard about interpreter-based languages like Python and JavaScript versus Rust is, yes, it takes you a little bit longer to get going, because you have to learn about, how immutability and how ownership works, and it kind of changes the way that you're thinking about programming. But once you have it, then you can continue with the same velocity, even when your application has scaled and has grown a lot more popular. Versus a lot of the time, I have seen this with Python and JavaScript. Maybe it takes you a couple of days to get going, and that's awesome to go from zero to having an application really quickly. But if your application does become serious and becomes popular, and it becomes very complex, and it becomes almost impossible to track down where it's being slow, where a bug is happening, because everything is happening in runtime and you can't observe the actual bugs. So it's all a trade-off, I would say. But we've liked the side of the trade-off that we ended up on.
Very cool. All right. Well, we're at 27 minutes, so that's a perfect place to stop. Ryan, any other things you wanted to drill into on Rust, or Danielle, anything you feel like we missed?
I would actually love to talk about one more thing with Rust that I think a lot of people don't talk about enough is because of its performance comparisons to C and C++, people think of it as a back-end system level programming language. And even, with us at Momento, obviously we're using it to build an infrastructure product. But more recently, I've met more and more Rust developers through my involvement at KubeCon San Francisco, which is this conference that a lot of developers go to. And I have a whole Rust track lined up for folks there. And I've met a lot of Rust developers who is working on Rust for higher level applications for UI. So for instance, Amazon Prime Video completely adopted Rust to be able to use it because it compiles into WebAssembly and makes their UI just super snappy, super fast. That's something that with, Gen AI especially, people like snappy applications. They want things to be faster, and they want the application to be reactive. So I found that really interesting that it's not limited to system level programming. People are using it for UI and for front end applications.
That is interesting. I've definitely heard of people complaining about the heavy JavaScript load on clients, and traditionally solving that through like server side compiling. I've also heard of the heavy JavaScript load sort of being an undue burden on places with slower internet connections. Does the WebAssembly help with that?
Yeah, completely. I mean, I think part of the reason for server-side compiling is that you can compile it down to these minified bin packs, or I'm not a web developer, so I apologize. I'm not using the right words. But the idea is to front load the work and then just have the clients, like you mentioned, whether it's like a phone or honestly like a super simple tablet device, to do as little work as possible doing the rendering and things like that. So the benefit of WebAssembly, again, is that it compiles ahead of time into machine code, and then you can and it cross compiles over multiple platforms. So whether it's iOS, Android, or, some generic tablet device, it also, with power on mobile devices, that's key as well, is to lower power consumption. I don't want to give away too much on the Prime Video engineers talk, but yeah, they're rewriting all of their applications for Prime Video in Rust/compile to WebAssembly because they've seen such a big difference in performance and power consumption benefits. So yeah, I found that to be super interesting and sort of continuing to unlock the power of the language.
Yeah,
sweet. So this is a talk you've seen ahead of time because you're working on the conference?
It's a kind of like an abstract, I would say, that we're working on.
Okay.
But I haven't seen the full talk. Obviously, that's saved for the conference. But I'm excited for it, and it's not the only talk that covers Rust as a higher level programming language. It's it's the one that everybody can relate to because we all know what Prime Video is.
Sure.
All right, we have a lifeboat badge winner. We give a lifeboat when somebody comes and saves a question from the dustbin of obscurity with a great answer. Somebody asked, I have an input of type data on my page and I want to change the color of the highlight inside of it, and I don't know if there's a CSS selector for that. Well, Simon Jewell knows what to do, was awarded a lifeboat badge. Congratulations, Simon. And anybody else who's curious, we'll put that question in the show notes. Over 13,000 people have benefited from this little tidbit of knowledge. I am Ben Popper. I'm the director of content here at Stack Overflow. Find me on X at Ben Popper. If you want to come on the show as a guest or you have a suggestion for topics, email us, podcast@Stack Overflow. And if you like the show, the nicest thing you could do for us, leave a rating and a review.
I'm Ryan Donovan. I edit the blog here at Stack Overflow. You can find it at stackoverflow.blog. And if you want to reach out to me, you can find me on LinkedIn.
And I'm Daniela Miao. I'm the CTO and co-founder at Momento, a real-time infrastructure platform. You can find me on LinkedIn to connect further. And please follow us on Twitter at Momento HQ, or check out our website at gomomento.com.
All right, everybody. Thanks for listening, and we will talk to you soon.